Hello and welcome to this GCSE Computer Science video with me, Mr Goff, for MrGoff.com. This is the final video in the data representation series focusing on run length and Huffman encoding. Run length encoding, sometimes referred to by its abbreviation RLE, is the summarizing of patterns of data into frequency value pairs. It's only effective on data that has runs of consecutive data. In this example, you can see that each row has been summarized into frequency value pairs. You can also see how it's much more effective for some rows than it is for others. Huffman encoding is a method for compressing text. It works by first analyzing text and then assigning the shortest binary codes to the most frequently occurring characters. We'll have a look at it by looking at an example of trying to compress the term 10 tennis teens. We start by creating a frequency table that shows how many times each character occurs in the term we're trying to compress. This table can be used to create a set of nodes with each of the characters that we're trying to compress. These nodes should be organized in order of the highest to the lowest value. The next step is to combine the two nodes with the smallest frequencies. This will create a new node with the combined frequency. This goes into numerical order, as you can see here in this example. We then repeat this process, combining the two nodes with the lowest values that we have now. That will bring us to this situation, and then combining the two smallest nodes again will bring us onto this situation. Once again, we'll go ahead and combine the two smallest nodes. That brings us to this point with just two nodes left at the top level. Combining those into one node, we get this final diagram here. We can now add zeros for paths that go to the left and ones for paths that go to the right. What each letter should be compressed into, we now follow its path from the top of the tree to the letter we want to compress. So E, for instance, goes 0, 1. N goes 1, 0. T goes 1, 1, and you can see the pattern that continues. You can see how it has resulted in the most frequently used characters getting the shortest binary codes. You won't be asked to create a Huffman tree just to be able to interpret a Huffman tree and read from them. You need to be able to calculate the savings from using Huffman encoding. When we compressed 10 tennis teens, that is 16 characters, which in ASCII or 8-bit ASCII would be 16 bytes. Compressed, we get a string of ones and zeros there that is 40 bits long to represent the term using our Huffman encoded table. This is 5 bytes, so there is technically a saving of approximately 11 bytes. I've said approximately there because you'd also have to find a way of transmitting the table so that it would be able to translate the data. That brings us to the end of this video on run length and Huffman encoding. I've been Mr Goff for MrGoff.com. I hope you'll join me again soon when I'll be back with some videos covering the topic of computer systems. Bye for now.